Hello everyone and welcome to this section that we call the CEA Spotlight, where we are able to analyze research done by scientists in order to apply it to our systems. So today we are going to be able to analyze a research done by one of my favorite scientists working on LED lighting. His name is the Professor Eric Drunkle. He did a research along with Nathan Kelly, and this article is called Dependence of Far Red Light on Red and Green Light at Increasing Growth of Lettuce. So we are going to see the effect of red light in LED lighting for growing lettuce and how the effect of far red is on the crop when we are providing also blue light, green light, and red light. So let's start with the evaluation of this research. So let's start first with a quick introduction about far red. As we know, the photosynthetic active radiation are the colors that are usually linked directly to photosynthesis, and far red is outside of PAR, meaning that it's not directly related to photosynthesis until now, but we know it provides effects that can affect photosynthesis. So in this case, we know far red, for example, can make the shading avoidance response on our plants. This will affect our plant in terms of making the leaves more susceptible to light, and then that can increase leaf area, can increase photosynthesis, and it could increase the fresh mass. So that's why we need to evaluate if it's possible or if it's worth it to add far red into our lights in order to improve our crop production. As we know, far red can have an effect on our plants, and this effect can also be different depending on the amount of other colors of light that we have. So in this case, in this research, they were able to analyze different treatments where they were looking to replace colors like red or green with a far red in order to see what happens, to see if there is a trend or something that we can learn on how to apply far red into our light recipe. So for this research, they use a fixed photosynthetic photon flux, meaning they use the same light intensity for all the treatments. The difference between the treatment was the amount of far red, green, and red light that was used. They made 12 different treatments, all of them with a different proportion of far red, red light, and green light, and a fixed spectrum of blue light, meaning that blue light was the same for all the treatments. For this research, they had a hypothesis that decreasing the red and far red ratio by substituting far red with green light or red light will increase the fresh mass. So that was the hypothesis, but now let's learn about the result. So first, they learned that by substituting red light with far red light will increase the leaf area and increase the fresh mass, but until a point where the situation went a little bit not ideal in terms of quality and growth in the plant. So they also learned that green light had less effect on leaf expansion and also fresh mass in comparison to far red. But with a specific cultivar, they also found that the diameter of lettuce was higher when green light was totally replacing red light at the highest far red percentage. So based on the results, they were able to conclude that it's possible to add 25% of far red in order to improve fresh mass and also the leaf expansion. But if we increase too much far red, we can also get into a point where this situation will change, meaning that we won't have an effect on the fresh mass, and actually the plant will start to get a bad shape, and the quality of the product will be not ideal. So based on this research, we can know now that some colors that are outside of PAR can also be used inside of vertical farming systems, but it's always important to analyze how this will affect the efficiency of your system, which we know is very important in vertical farming systems. So there are different colors outside of PAR, far red, UV lighting, and now there's a lot of research done around these colors. Based on the results, we can start to evaluate the idea to add these colors into our systems. So if you have any questions, let me know at the comment section. I hope you enjoyed this quick summary of research done by Eric Drunkle and Nathan Kelly, and see you on the next video.